Hey everyone, welcome to today's deep dive. If you've got a physics exam coming up, or honestly, if you're just curious about how our universe actually works, you are in the perfect place. Today we're getting into the absolute bedrock of physics, Sir Isaac Newton's laws of motion. It's basically the rule book of reality, and we're going to break down these three fundamental laws using super simple everyday examples. That way, you're not just memorizing facts, you're actually going to understand them and totally crush your exam.
All right, here's our game plan. First up, we'll tackle that famous story about the apple and gravity. Then, we'll walk through the three laws: inertia, mass and force, and reaction. And to wrap it all up, we'll pull everything together into the ultimate cheat sheet for your test. Let's get into it. Section 1. The apple and gravity. Let's separate the myth from the reality.
Picture this. It's England, 1665. Isaac Newton is hiding out from the Great Plague at his Woolsthorpe Manor. And this is exactly where the most famous myth in science history is born. Newton is peacefully sitting under a tree, an apple drops right on his head, and bam, he instantly discovers gravity? Sounds like a fun cartoon, right? But did that actually happen? Spoiler alert, no, he did not get bonked on the head. According to his friend William Stukeley, Newton really was walking in his garden and did see an apple fall, but there was no head injury involved. That simple observation just got him thinking, why do apples always fall straight down to the center of the earth? Why not sideways? Why not up? The apple was a catalyst that sparked years of thought, not some instant light bulb moment caused by a falling fruit. Let's move on to Section 2, Newton's first law, the law of inertia, or as I like to call it, why objects are incredibly lazy. Here is the exact definition you need for your exam. An object's motion will not change, meaning it'll stay still or keep moving unless it's acted upon by an outside force. Basically, objects are super lazy. They want to keep doing exactly what they're already doing. They literally need a push or a force for anything to change. Picture some laboratory flasks just sitting peacefully on a table. Unless an outside force acts on them, like someone bumping the table or swiping them with a hand, they are going to stay perfectly still forever. That's their inertia, their total, absolute resistance to change. Let's look at two everyday examples. First, a stationary object. You know that classic magic trick where they pull a smooth tablecloth out and all the dishes stay right on the table? Why does that work? Because the dishes were at rest, and thanks to inertia, they really want to stay at rest. Now, what about a moving object? Imagine you're in a car and the driver suddenly slams on the brakes. Your body wants to keep moving forward at the exact same speed the car was going, and that is exactly why we wear seatbelts. The seatbelt provides that crucial outside force to stop your inertia safely. Now, you might be thinking, wait, if a moving object is supposed to move forever, why does a ball rolling on the grass eventually stop? That's a great question. The answer is invisible forces. Even when it looks like nothing is there, objects are always dealing with gravity pulling them down, friction rubbing against them, and air resistance pushing back. For example, if you drop a feather, gravity pulls it down, but air resistance pushes it up, which is why it falls so slowly. All right, part 3. Newton's second law, mass and force. This is where we figure out why heavy stuff is just harder to move. For your test, remember this. Newton's second law states that heavier objects need a larger force to move them the same distance as lighter objects. Honestly, it sounds like plain common sense, right? But Newton was the first one to write it down as a universal rule for the entire cosmos.
Let's compare two scenarios. If you tried to push an empty shopping cart, it takes barely any effort at all. But to get a heavy car to move with that exact same acceleration, you'd have to use a massive amount of force. Here's a relatable example you've probably experienced at a playground. Imagine two kids on a swing set, a 3-year-old who weighs about 15 kilos and an 8-year-old weighing 30 kilos. If you push both of them in the back with the exact same amount of force, what happens? Second law in action. The heavier kid simply won't swing as high as the lighter toddler. To get the older kid to swing just as high, you literally have to push them twice as hard. We're almost there. Section 4. Newton's third law. Reaction. Let's see how forces always work in pairs. This is probably the most famous phrase in all of physics. Newton's third law. For every action, there is an equal and opposite reaction. Every single interaction in our universe is basically a two-way street, with two forces pushing in opposite directions. This law is literally how we go to space. Think about a rocket launching.
There's an intense chemical reaction inside that blasts super hot gases downward. And what's the reaction? That downward action creates an absolutely equal force that thrusts the rocket upward. Need a few more examples for the exam? Easy. If you throw a rubber ball hard at the ground hits back. It pushes the ball upward with the exact same force, making it bounce. Or here's a classic one, and a warning so you don't end up soaking wet. Imagine standing in a boat and trying to jump onto a dock. When you push your legs forward, that's your action, you are simultaneously pushing the boat backwards. That's the reaction. If you forget that rule, the boat slides right off from under you, and you're going into the water. And finally, Section 5, the exam cheat sheet. Let's do a quick recap of everything we've covered.
Okay guys, time to pull it all together. You might want to take a mental snapshot of this grid for your test. First law is inertia. Your keyword is the seatbelt or the tablecloth trick. Second law is mass and force. The heavier it is, the harder you push. Remember the kids on the swing. And the third law is action and reaction. Just picture the rocket blasting off by pushing gases down to go up.
You know, physics isn't just a bunch of dusty formulas in a textbook. It's the operating manual for everything around us. So before we wrap up, I want to leave you with a challenge. Look around the room you're in right now. Which of Newton's 3 laws is acting on you at this exact second? Think about it. Thank you so much for joining me on this deep dive today. Keep studying, stay curious, and I'll catch you next time.